Welcome to the second video for Chem 8, which is a review for the coming common exam, which is on May 13th. So this is a continuation of video number 1. If you've not watched video number 1, that was a mistake, and you need to go back and do video number 1 before you watch this one. Otherwise, it probably won't make sense. Okay, so what are we doing here? All right. So there's other ways to represent periodic tables, and what you're looking at here as a different representation is period 2. All right, and I've labeled the group numbers going across, and we're not showing anything else on the table itself, just period 2. All right, and this gap in the middle is where the transition metals would be. They would actually be one more layer down. So this is period 2 going across here. I'm just going to put this arrow here to indicate that they should connect. All right, and the element that would be over here would be neon if I wrote it in here, right? And next door to that would be fluorine. And next door to that would be oxygen. Next door to that would be nitrogen. Next door to that would be carbon, for example, and then this would be boron. And underneath boron would be aluminum. All right, and over here we're going to have on the far left side, this would be sodium. No, sorry. Got to keep track of where I'm at. Okay, this would be lithium. And then this would be beryllium. Okay, now, so like I said, there are other ways to show periodic tables. And we're looking at a representation of period 2. And you'll notice that in the boxes, instead of having the elements in there that I drew in red underneath, that there's a coding system. So if you see something like this on the common, you need to be aware that all they've done is coded the elements that normally would be in those boxes. So the first thing I recommend if you're confronted with something like this is to just do what I did here and sketch in, what you know to be the elements that belong there. All right. And then in terms of, the types of questions that you could or could not be asked, we're going to practice a few problems here. So here's an example where we're combining a group 1A element with a group 6A element. All right, and again, 6A is over here, and the key thing about this to remember is that you got to pay attention to your diatomics. If you're going to be writing chemical equations and balancing them, then you need to remember that any of the elements that are diatomic have to be represented that way. So for example, the 6A element here could be oxygen as an example, and it would be written as a diatomic. A 1A group element, right? This could be lithium, sodium, potassium, whatever. All right. Why don't we just use sodium for the heck of it? All right. And then remember, this is a synthesis reaction because it involves the combination of two reactants literally to make, one product. And so now what we need to do is figure out what that product is going to be. And we also need to balance the equation. So I'm going to put a plus sign here like this. All right. And then I'm going to put an arrow here like that. All right. Now, again, to answer a question like this, you need to be up on your elemental ions. God, I've said this all year long. And if you're sitting here watching this right now and you still don't know what Na ionizes to, or a group 1A element ionizes to, that's a problem. All right, so when this thing reacts, it's going to lose one electron and it's going to become Na+. That's true for any of the group 1A elements, all right? And this dude right here, the O2, right, it's going to be blown apart, and basically it's going to ionize to O-2. And you should know that from your elemental ions. So the product over here is going to look like this. It's going to be Na, and we need 2 of them, right? Because this is +1 and this is -2. And we need 2 Na pluses to neutralize the -2. All right, so this is going to be Na2 and then O. All right, so now when we go to balance this, because you can see that we needed two NAs here, but there are two O's here, right? So there's going to have to be a 2 in front of this. And that means we're going to need a 4 in front of this originally, and then the O2s are fine because there's going to be 2 of them. So this would be the correct, this would be the correctly balanced equation. Now, what if we did this in code? So look up here. In 1A, they gave us a D, so I'm going to write that down. And it is reacting with, let me change the color, with 6A, which in this is an I. All right, and what you need to be able to do to predict the product, right, and then do the balanced equation is say to yourself, okay, what is a D? Well, I just took you through this example. It's going to be any of the elements that are in 1A, right? So this is going to ionize to D+. And this guy right here, in reality, remember, is actually going to be, it's out of 6A, right? So it should be I2. And when it ionizes, it's going to go to I minus 2. So you would write the product over here as D2I. And then you go through the same process to balance this thing. So this should actually be I2, right? And so this is going to be 4 D's plus I2 to make 2 of those guys right there. All right. Now let's apply that to the next example down here. So this is saying we have a 2A metal, and they're calling it E. So remember that these dudes all ionize to E plus 2. And we're reacting this with a 5A element. And the 5A elements are going to be nitrogen, which is going to be N2, right? It's diatomic, and then phosphorus underneath that. But if you encounter something like this on a test, I think they're going to probably stick to, you know, the easier elements. But if they don't, you're just going to make this P2. That's what you're going to do. All right. So for this one, we're going to have, as an example, let's see, in the example up above, it's going to be H. This is going to be H2 though, because it is diatomic, right? It's N2. And then we have E as an exchange for the magnesium. So when these two things react, and why am I talking about that? Because we need to figure out the question mark here. So this guy here is going to go E plus 2 when it reacts with the H with the H. Now, this is not hydrogen. This is the code that they used. That's why I'm calling this H2. Don't confuse this. You got one eye on a computer game right now and one eye on this, you're probably going to be lost. So when this ionizes, it's going to go to H minus 3 because it's out of 5A. And 5A, when nitrogen is ionized, goes to N minus 3. That's why we're doing it this way. So when you go to produce this product, right, we're going to do, the easiest thing to do is to do drop charge. So this is going to come down like that. This is going to come over here like this. So we're going to have E, 3 of these, and then we're going to have H, 2 of these. Now, if you just do the math, the H is worth minus 3. There's 2 of them. That's a total of minus 6. And then there's 3 of the E's, which are plus 2. That's plus 6. And the total here is going to be 0. All right, last example. We're going to have an element out of 3A. So you know what? I'm going to use aluminum and not boron. And the reason I'm going to do that is because it's most typically the element used out of that group. And so we're going to have an aluminum here. And we're going to be reacting that with a 6A element. Most likely it's going to be, let's see, where's my 6A here? It's right here. So again, think it out. Most likely the reference is going to be oxygen, but they used an I in the box. So I'm going to write my I here. And because it's coming out of 6A, it's diatomic, right? And then what are these two things going to form? Well, remember, when aluminum ionizes, it's going to go to Al plus 3. And when oxygen ionizes, it's going to go to -2. So this is going to be I minus 2. So now you can do the drop charge method, and the product that we're going to get here, let's see, what I want to do, I need to replace this with what they put in the box. So the aluminum, they used F. All right, so what I'm going to do over here is we're going to have F2, and then we're going to have I3. And that is the same as Al2O3. Hopefully you're getting the gist of this, just in case, you know, instead of using actual elements on a particular test, instead they're using a code or something. Who knows? All right, anyway, I'm going to close the video.